Lewis structures were created in the early 1900s by Gilbert Lewis. This video will review a quick way of creating the Lewis dot structures for molecules, in which we use three simple steps. First, we want to make sure we know the total number of valence electrons. Then we want to know how many of those valence electrons are involved in bonds. And finally, what are the number of electrons left over? These we call non-bonding electrons or lone pair electrons. Now keep in mind that this video does not work with the octet exceptions, nor are we looking at any kind of structure that involves a resonance structure where there are multiple possibilities. Now, a little more detail on each of the three steps. The first thing that students need to keep in mind is in step 1, where we count the total valence electrons. In this case, we use the group number for our representative elements. Transition elements we need to be a little more careful with, so we generally work with representative elements when we start in high school. Now, the total valence electrons are simply the group number, so the 1A, 2A system helps us very well on that. Next, on the bonding electrons, we want to watch and keep in mind the 4-3-2-1 rule. Now, what we mean by that is that carbon always wants to have 4 bonds around it. Nitrogen tries to get 3 bonds, oxygen 2, and then the halogen and the hydrogens, they want to have 1. So let's look at an example such as methane. Now, methane happens to have a carbon atom and 4 hydrogens. So in our table, we'll write the carbon and the hydrogen, and then we'll write down that we have 1 carbon and 4 hydrogens. Next, we look at our periodic table, and we learn that carbon is in group 4A. We're going to put down that it has 4 valence electrons, and hydrogen is in 1. Therefore, it has 4. We add them up, and we end up with a total of 8 valence electrons. Next, we look at how many bonds are involved. Now, carbon typically wants to have 4 bonds. So we're going to put 4 lines representing these valence electrons. That would be a total of 8. We put our hydrogen around, and we note that hydrogen only wants to have 1 line, or 2 electrons, and therefore we have already shown all 8 electrons. There are no non-bonding electrons in methane. It's a very easy structure to keep in mind. Now let's look at our answer, and we notice we can list our answer 2 ways. We can either show the dots or just show lines. So if we circle around the duet, we can see that we have completed the duet rule around the hydrogens. And when we circle around carbon, we see we have 8 electrons around the carbon. So we have, in fact, done our Lewis dot structure properly. The second example is hydrogen chloride, and we have 1 hydrogen, and we have 1 chloride ion. We look on our periodic table. We know that halogens are in group 7. We add them up, and we have, again, 8 electrons. But this time, we are only going to have 1 bond that shows between the hydrogen and the chlorine. This means we have shown 2 bonding electrons. We have 6 electrons left. They can only go around the chlorine atom. So we'll redraw our molecule showing the bond, and then we will put in non-bonding electron dots to show the other 6. Once we've done that, we don't have any valence electrons left, and if we check our answer, we see we are in fact correct. We've satisfied the duet rule around hydrogen and the octet rule around the chlorine. I hope this helps.